this practice, we are going to apply the principle of solid-state diffusion to cement carbon steel rods in order to increase the mechanical properties of the outer layer and provide adequate tenacity in the core of the part. All after this, we are going to analyze the effects of cementation variables on the results obtained. The materials that we're going to use are steels 1080, 4140 and 1045. Also, we're going to use protective equipment for high temperatures, movable oven with temperature up to 950 Celsius, the aerometers for the biggest test, the equipment for metallographic preparation to see the change in the grains. Also, we are going to use an iron box with lid and tweezers for the iron box.
At the laboratory practice, the teacher gives us a 1018 steel. The first step was to cut 3 pieces into slices of 1 cm thickness using the disc cutter. Then we remove the boards and leftovers of material using bench grinder and mark the type of steel and the number of the team in each sample using the marker machine. The second step was to crush the coal that is used for the cementation and verify the amount that we were going to use for this procedure. For this, we need to calculate the percentages we need to weigh the coal in a balance. Then, in the third step, we prepare the mixture based in the percentages. This was 83 to 87% of vegetal coal, sodium carbonate at 2 or 3%, barium carbonate at 10 to 12%, and calcium carbonate at 3 or 4%. For this, we use a digital scale and mix all the components until we have a heterogeneous mixture.
After the mixture of substances was made, a lower bed of cementitious material was placed on the base of the box. The samples were deposited, leaving enough space between each other and covered completely with the mixture that was made. Once the pieces and the filling have accommodated, the lid of the box was sealed with clay. The oven took about 2 hours to get to the right temperature, 900 degrees, and the first heat treatment was going to begin. The first one was about 12 hours inside the oven. After, it was going to cool down in the box outside the oven, and the other 2 pieces were going to be heated to the recrystallization temperature for 15 minutes and then quenched in water as well. Once quenched, turned half in temper for 15 minutes at 200 degrees.
Carburizing is a heat treatment process in which steel absorbs carbon while the metal is heated on the presence of a carbon-bearing material. Depending on the amount of time and temperature, the affected area can vary in carbon content. Carbon equivalent is a concept used on ferrous materials, typically steel and cast iron, to determine various properties of the alloy. Cemented layer. The cemented layer is the outside layer of the material which hardness changes due to the cementation. The applications of cementation are to increase the percentage of carbon on the outside layer or the cemented layer, as previously said, of the material used during the heat treatment. The cementation steels are low carbon steels, which makes them appropriate for this heat treatment, making them easy to work with them, easier to weld, and they have perfect toughness. The types of cementation are basically 3, which are box cementation, the one that we use on our practice, the liquid cementation. This type of cementation is faster than the previous one. This method allows better penetration and makes the carburized layer more homogeneous. The third one is the gas cementation. The steel piece is placed in a furnace with a gas atmosphere made of hydrocarbons. It is faster and precise method than the previous ones, which allows you to cementate many pieces at once. There are basically two types of furnace to create this cementing, which are the continuous furnace, allowing you to have big production of parts and to make a lot of pieces, and the basic furnace, which is like a room, but it's the traditional way of cementing. In this furnace you can have big productions because of the opening and closing to extract or take the pieces already heat treated.
In the TTD diagram, the first step was to heat to 900 degrees for 12 hours so we can obtain austenite. Then we cool in the box. Then we reheat to 800 for 15 minutes, that recrystallization, where there we also obtain austenite, but different. The next step was to quench in water. Then we temper at 200 degrees Celsius for 15 minutes, where we obtain martensite, and we cool to room temperature. As we can see in the hardness plot, in everyone they get a higher hardness in the outer layers because of the cementation. What the cementation makes, it increases the percentage of carbon on the outer layers, and in the center maintains the same the carbon we have. So that's why we have higher hardness in the outer layer. And as we can see in every plot, we have a higher in the first test, and as we move to the center, there is a less hardness.
To determine the depth of the carburized layer, we have all this data: time, temperature, and the concentrations of carbon on the surface at the beginning and on a point of the piece. This is the formula we're gonna use first of error, and we're gonna solve using the concentrations, knowing or getting that is 0.911, and from the tables we're gonna get that Z equals to 1.2. Now we know C, we have to solve for D, so we can solve for X on the C formula. Solving for D, we get the value of 2.42 times 10 to the minus 7, and knowing that C equals 1.2, we solve on C's formula for X, replacing the temperature on Kelvin and getting a final value of X equal to 0.2.
In this practice, we saw the apply of the principle of solid-state diffusion to cement carbon steel rods, and we saw a increase in the outer layer in the hardness because when we did the analysis, the metallograph analysis, we saw the change of the grains, and these were strongest than the original part. So also we now know the procedure for do this. This is cheap, expensive, and is the most easy way to do this and the cheapest thing.
With this laboratory practice, the team applied the principles of the solid-state diffusion to cement carbon steel rods, and now we could see how the mechanical properties increased, and now we can see it practically and not just in the theory.
What I learned in this practice is how to do a cementation process, and how it is useful, how it functions, that in the outer layers it's more hard than in the center, and to know all the properties.
Conclusion is that this is a very useful treatment because you can adapt a low carbon steel to whatever need you need depending on the concentration of the carbon you want to add it on the surface, because if it is soft you can make it a little bit harder with this heat treatment without having to change the whole properties of the material as it is, having the soft nucleus and the hard surface.
Before this laboratory practice, I can conclude that I'm applying all the theory that we learn in the classroom. Also, I'm discovering that the materials have a lot of ways to be treated to obtain better properties. I think that the cementation is very useful in the real industry because you can obtain a hard exterior but a soft interior.